Back then, I used to steal paper, and I used to borrow the paper on copy machines in the library. And I went through a lot of paper. Because I wrote the questions out I didn't write the questions out. I solved all the problems again and again and again. So as we're going through stuff, we want to solve these again and again and again. Now, the take-home quizzes, you can bounce that off each other, correct? And once you get the correct answers and you know the correct answers, you should be going through those questions over and over and over and over. Because what's the test going to look like? Kind of going to look like the quiz questions.
Sarah, I'm your SI leader, supplemental instruction. So there's 2 different things that I do. I have an office hour on Fridays from 11 a.m. to 12 p.m. In the computer room, portable Phillips. It's right across from the elevator. You take the elevator up to the 4th floor. And then I have SI sessions. Mondays from 5 to 6:30 and Wednesdays from 4 to 5:30 in Centennial 3814. So at that session, beforehand, I plan out like different review activities where we're doing more problems, more practice. You guys get to work together. And I try to make them fun and try to make the games out of it. And that way you get that more practice of Dr. Peter saying so that you really understand the material. And it's okay if you can't come to every single session. You can just come to one day of the week. And try to come whenever you can to get that conversation. And my email is there as well if you want to email me if you have specific questions about what SI is. And then also I have this schedule on the pins page as well.
All right, let's do questions on the quiz. Let's start with this one. Somebody yell out a number. What do you want to, which ones did you struggle with? Something like that. Let's look at quiz questions on this baby. One, 2, 5, 11, 13, 17, 24 through 40. Any questions on those? Yes. 6. All right, we're going to look at 6. All right, so we should, for potassium thiocyanate, we've got potassium should be K, and my thiocyanate should be on the pink sheet as the alphabetical order on the pink sheet as CN. Now my potassium is always +1. My SCN is -1. So we should be looking at something like that. What else do we have on this baby? Quiz questions. Yes. 5. So for 5, we have aluminum +3, nitrate, polyatomic ion, NO3 -1. So we need another nitrate -1, and we need another nitrate -1. Once we've got 0 across the top, that accounts for all of our electrons lost to form a positive cation. And then it accounts for all of our electrons gained to form a negative anion. So we're going to need parentheses out of that, right? Else on this quiz? Yes. 24. 24, 24, 24, 24, 24. Okay. On 24. So we have MNN. Now, this right here has to be negative. The only charge, manganese has to be positive, and manganese can be many, many charges, oxidation states. But my nitrogen here, the only negative is -3. So if my nitride is -3, my manganese has to be plus 3, right? And we have to have Roman numerals for this. We have to have Roman numerals. So it looks like we've got this first one here, huh? Okay, anything else on this one? Yes. Yes. Oh, no, you'll get a periodic table for the test. So you can use the periodic table and green sheet for the test. Yes. You're saying manganese, it says a -2? On have a different table? Oh, you got it from me? So your nitrogen here is different? Oh, is that those first ones I handed out? Who's got one of them? Oh, you're right. Right. I've never seen that in my, oh, wow. You're right. I got to start handing out only one table. You're right. I've never seen that before. Wow. Yes. 2-0. I had to help you out with this one. Oh, did I sign 20? No, I didn't sign 20. We don't want to do 20 yet. All right, anything else on this one? Yes. 15? 15. Then we're going to switch to the other one. 15. Okay, so 15 looks like this. I'm going to write it on this sheet. We've got Na2WO4. Na2WO4. So we want to figure out what the oxidation state here of tungsten is, so we can expand this out. Other than my messed up nitrogen. What's the charge of our oxides here? Oxidation state of our 4 oxides? -2, -2, -2, -2. My sodium is always +1, +1. So in order to get 0, my tungsten has to be and then you should double check. Can tungsten be a 6? And look right here. It looks like it can be a 6. In fact, my tungsten here is bold. That's what it is most often. It's 6. All right. Nobody asked me the more difficult ones, so I'm going to do this quick and we got to move on. 31, 32, 33, 34, 35. Which of these is written correctly? You have to go through these individually. So I'm going to look at 31A. You have to look at these individually. BOOO. -2, -2, -2 makes it a boron 6. Is there a boron 6? No, 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 no. Junk, junk, junk. That's junk. You got to go through every one of these individually. There's no such thing as boron 6. That's junk. Now, B, you've got W, CO3, CO3, CO3. What is CO3 and what oxidation state does it take on? So you would scan your pink sheet under the C's, scan your pink sheet under the C's, find CO3, find CO3. That is Carbonate, -2, -2, -2. What's this make my tungsten? +6. Is there such thing as a tungsten 6? It looks like that's a good one. Let's explain why the other ones are junk. Let's go to C. You've got LiClCl for C. What negative charge does chlorine take on as a chloride? -1, which makes this lithium a +2, correct? Is there a lithium 2? No, lithium is always +1. In letter D, we've got Zn, ZnS. Negative charge for sulfide. Sulfide, -2. So if the sulfide's -2, the only way for that to work would be to make each zinc +1. There's no such thing as zinc 1, that's junk. Then for letter E, we've got CaOO, oxide, -2, -2, -2, makes the calcium a +6, and that's just garbage, right? Calcium can only do 2. So for these, you should be able to verify each letter like that. And only one is written correctly. All right, let's close the book on this baby. This quiz, how are we doing on this? 1 through 13. Any quick, I'll take like one question on this baby if you've got it. On this quiz. All right, let's look at what we did last time. Ended with this slide here, and I don't really have time to talk about this at all. And Al does this a little bit. But I think the very end of the Al does a question that relates to this. For properties of ionic compounds, a metal atom can transfer an electron to a non-metal atom. The resulting cation and anion are attracted to each other by electrostatic forces. Opposite charges attracting. So, and then we have a distance between their nucleuses. So here's lithium fluoride. This is actually Coulomb's law. The force depends on the charges and the distance. But I think what Al does, without going into this, if you have NaCl, +1 and -1. So we've got a positive ion force of +1 and a -1 here. That is going to have less force than this because we've got a +2 and we've got a -1. It's just we've got a higher charge, so we have more force. That's about as much as I want to get into this. And I think, doesn't Al do this at the end? Doesn't Al have a question like this towards the end about which one has higher force or something like that? Oh, okay. I thought it did. Okay, let's go then to writing our formulas of compounds. Let's finish up that because we've got acids to do here. So we're going to finish this up and go back. I want to just go through page 5. On page 5. On page 5. For ionic compounds, this box on page 5, I want to clarify this for sure. For ionic compounds, how do you know if you have an ionic compound? For the most part, you're just starting with a metal. We could name those two ways: manganese trioxide or manganese 6 oxide. If you have a molecular or covalent compound, you've got nonmetals together, we'll use prefixes only. So for number 28, you should have gotten, if you use a prefix, tungsten trioxide. And then what is the Roman numeral? And we have tungsten 6 oxide, right? Yeah, you'll see these, it's the same compound, so sometimes the both names will be used. But it's the exact same compound. Okay, let's go to page 6. Page 6 is formulas of acids. Formulas of acids. So for now, how do you know if you have an acid? It's going to start with a hydrogen ion. And then you're going to have a negative here. So it says, write the formula for the following non-oxyacids. What does non-oxy mean? Well, no oxide or oxygen. So all non-oxy acids will start with hydro, end in ic. Start with hydro, end in ic. And there's kind of a mnemonic for that. So my ride has hydraulics. When you see the word acid for all of these, H plus 1, H plus 1, H plus 1, H plus 1, right away. Starts with hydro, ends in ic. So you have a positive ion, you have to have a negative ion that does not have oxygen in it or oxide. So if you look on your pink sheet, O on there, you're going to find iodate and iodide. Iodate, iodide. And it cannot, the ion cannot be iodate because it has oxide in it. So this is simply going to be HI. All of these are going to be a single ion with a negative charge, a single ion with a negative charge. So here we're going to have sulfide. Now, there's some freakish things that take place. Sulfur keeps this UR in here. You would think it would just be hydrosulfuric acid, but it's hydrosulfuric. -2. So we have H2S for hydrosulfuric acid. Hydrochloric acid. From chloride, just a Cl-. And then if you ever watch Breaking Bad, hydrofluoric acid, 55-gallon barrel to take care of a body. Hydrofluoric acid, F -1 from fluoride. So again, these are non-oxyacids. They all start with hydro, they all end in ic. Notice there's no oxides, right? And these are really simple. You've got the positive hydrogen, you've got a single negative ion here. All right, so let's go to oxyacids. So for the oxyacids, now you're going to have oxide in them. And these are even, well, they're pretty simple. Oxyacids contain oxygen. Really, the term should be oxide. And if the negative ion ends in 8 from the pink sheet, change the name ending to ic. I8 something. Eight to ic. I'll show you that. If the negative ion ends in ite on the pink sheet, change the name ending to OUS. So 8 to ic, ite to us. So here we have phosphorus acid. We have the word acid, H +1. So if we have OUS, we need to look on our pink sheet. Find something that ends in ITE, negative ion. Looks like that, ends in ITE, alphabetically under the P's. Very top, right? Phosphite. Phosphite, PO3. And another freakish thing, phosphorus compounds keep the OR. So we're going to need 3 hydrogens. Perchloric acid. Perchloric acid. H +1. Perchlorate. Perchlorate. Perchlorate, ClO4. This one. Here, OUS, we're going to be looking for ITE. IC here, we're going to be looking for 8. IC here, we're going to be looking for 8. OUS, we're going to be looking for 8. And IC, we're going to be looking for 8. +1 for all these, right? And then put them up. Next page. So the next page is doing the opposite. It's looking at a formula and writing down the correct name. So as soon as you see something starts with hydrogen in this case, starting with hydrogen, acid, 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 all the way down the page. So it starts with hydrogen and there's no oxides, correct? Starts with hydrogens, no oxides. So we know the name is going to be hydro, 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 hydro. We know it's going to end in ick, 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 ick. We just got to fill in the middle now. Fill in the middle. What is this going to be? Hydrobromic. Next one is going to be hydrofluoric. Now, again, number 3, you'd think it'd just be hydrosulfate, but it is hydrosulfuric. Keep that UR, and for number 4, hydrotelluric. And then for the oxyacids, all you need to do is look up the negative ions here. Got some freakish ones. Let's do 5 and 6 first. What on a 5 and 6? ClO3. LO3 is chlorate. ClO3 is chlorate. Right next to it, let's write down ClO2. ClO2 is chloride, right? So the acid names are going to be chloric acid here and phosphorus acid here, right? 8-ic-itos. SiO3 is under the M's. It's not, you won't find it under S. So I remember I put these letters here to help you find SiO3 on your pink sheet. So find SiO3 on your pink sheet. And that is metasilicate. So we're going to replace the 8 with ic. Yes. Okay, try to finish page 7 and try to do 8. I've got arrows down there. Try to do 7 and 8. Try to do 7 and 8. That'll get us through acids, and this actually is in the next chapter. But since we're writing formulas of compounds, it makes more sense to do it right here. So try to do through page 8. Again, you should be able to find her, but the answers are in Canvas, right? There's a scan of this with the answers in Canvas? Yes, yes, okay. Yeah, there's a scan in there. Okay, let's go to our other learning guide. And then we are going to start Chapter 2, Part 2 under OWL, which is all about moles. So we got to work on some moles here. Okay, now let's look at things on our periodic table first. And I just zoomed in on beryllium. So beryllium here, 9.012182 is the average atomic mass of the naturally occurring isotopes. And remember, we looked at that. In fact, we calculated magnesium, right? This was the weighted average, and there was 4 isotopes, 3 or 4 isotopes for magnesium, right? What unit is this? This is atomic mass unit, right? Which is really, we're talking about the mass of an atom. We're not going to go into the chemistry lab and say, hey, mass out, give me 10 atoms of magnesium, right? But I can tell you to mass out 10 grams. You can mass out 10 grams, right? Now, what makes all of this massing in the chemistry lab possible is if we're talking 1 mole of magnesium, it would be 24.305 grams. If we're talking 1 mole of beryllium, it would be 9.012 grams. Not only that, it would be 6.022 times 10 to the 23rd atoms of these. Now, the 6.022 times 10 to the 23rd is just another definition. How many are in a dozen? 12, right? So let's say you're in the fruit business. You're going to make up a table of your fruit. And every fruit you sell from, tomatoes is tomato or fruit? I don't know. Tomato fruit, I guess. Tomatoes and, right? You got apples and oranges and grapes and all that stuff. Could you make a table out where it's going to be, you're going to sell them by 12s, a dozen, right? Could you have a weight of all of those made up in a table? And when you looked at that weight, you already know that is 12 of them, correct? It is no different than this periodic table. You're looking at a table that when you look at this number, it is the mass in grams. And how many atoms? 6.022 times 10 to the 23. Could we have done this table with 12 of them? Sure. But this table works when we have a mole. How many are in a mole? 6.022 times 10 to the 23rd. So if we look at this, here's sulfur, 32.066 grams. How many atoms of sulfur? Because that matches our chart. 32.065, 32.066. 6.022 times 10 to the 23rd atoms of sulfur. This matches our magnesium. We've got 1 mole. 6.022 times 10 to the 23rd atoms. Tin, 118.71. 6.022 times 10 to the 23rd atoms of tin. And so on. But once we start combining to make compounds such as water, you look at hydrogen on your periodic table, 1.00794, and oxygen 15.994. But we've got 2 hydrogens, correct? So we'd have to multiply this by 2, add these together, and we get round to the 2 sig figs, the molar mass of water, 18.02, right? That is a mole. How many water molecules? Notice I use the term molecules here, atoms up here, correct? 0.023 times 10 to the 23rd. So let's go to the next page here. Now, if you miss class, and if I have the links in here, it depends on some of these. I have the links. Do I have my own links in here? It's not. This class, I guess, grab the YouTube video. Otherwise, you might see my name here sometimes too. And it's a direct link for this sheet. Otherwise, this Tyler DeWitt is excellent. If you've clicked on any of his videos, they're excellent. All right, first question. What is the molecular weight, molar mass of ibuprofen? C13H18O2. We have a compound. So to get our molecular weight, we need to take 13 carbons. Now, you're going to start memorizing these. You're going to start memorizing these for sure. Carbon. 12.01 from your periodic table. Hydrogen, 1.00794. We'll use 1.01. We'll use 2 decimal places for these. In oxygen, 15.9994. We'll go 16.00. You will start memorizing those. So, right from the periodic table, right? Carbon 12.01, oxygen, we're going to use 16.00. Hydrogen, we're going to round to 1.01, 2 decimal places on everything. So the molecular weight, 13 carbons at 12.01. Now, I'm going to put this in two. Oh, no, not. We'll put it in at the end. 13 plus 12.01, 18. 18 hydrogens at 1.01 plus 2 oxygens at 16.00. Grab your calculators. It'll do it just like that. At 206.31. Okay, now listen. It would be 206.31 AMU if we were talking about a single molecule. But molar mass means we have a mole. Therefore, our molar mass is 206.31 grams in a mole. In mole, I guess I'll put the E on for now. Single molecule, we'd call it atomic mass unit. Otherwise, here, grams in a mole. Okay, molar mass for, what's the name of this compound? Aluminum sulfite in this case. Typically, it's an SO4, it should be a sulfate. It's a sulfite. Now, how many aluminum atoms? Two aluminums. You have two aluminums. Then you have SO3, 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 right? You have 3 sulfites. So to add this up, grab your periodic table. We have 2 aluminums, 2 decimal places on the molar mass of aluminum. What do we get? For aluminum, 26.98 plus 3 sulfurs, 32.07 plus how many oxygen? 9 oxygen. And if we add these up, two 294.17, 294.17 grams in a mole. All right, let's convert back and forth. Here, we are going to do, oh, my arrows didn't show up. Do you get any arrows to print out here? Do you have arrows? Anybody got an arrow right here? No, my arrows didn't show up. Weird. Here, we're going grams to moles. Here, we're going to go moles to grams, grams to moles. My arrows are missing. Weird. Okay. Here's what we're going to use for a conversion. 1 mole. we might use a term of an atom, a molecule, or a formula unit, or we might have an ionic compound. Doesn't matter what it is, it's going to be 1 mole grams. It is the same, 1 mole to grams. Now, this is going to be the grams in a mole. This is going to be a double unit number. This is my single unit number. So for example, here, we're going to start with 4.7 grams of potassium. And we're just going to keep flipping the double unit number when we need to. If we're going to look up potassium in group 1. We're going to put grams of potassium down here, 1 mole of potassium up here. This is my double unit number. I'm going to flip grams and moles and grams all the time. How many grams of potassium in a mole from the periodic table? $39.10. 39.10 grams cancel out. And to 2 sig figs, what I get? 2 sig figs. Do I get 0.12? Now, I don't overthink this. Do not overthink this. Start with a single unit number and then 1 mole. It's always 1 mole. I'm starting with grams in this case. The next problem, I'm just starting with moles. Here is my single unit number. We're just going to start with my single unit number. Let's take that out of scientific notation. 9.2 mole of argon. If I start with grams, my grams go down below and my 1 mole goes on top. But if I start with moles, my 1 mole is going to go on the bottom and my grams is going to go on top. But again, it's 1 mole, right? And if I look on my periodic table for argon, I got 9.95, huh? And my units are going to cancel out, right? You know you have it correct if your units cancel out. To 2 sig figs on this. 0.037? All right, 0.037 grams of argon. My third example, I'm going to go grams to moles and then moles to atoms. My arrows did not print for some reason. got lost somewhere. No, sure. Now, in chemistry, if you're not given moles 99 times out of 100, you're given something else, first thing you should do is find moles. So 5 grams. That's my single unit number. I've got 3 sig figs, 5 grams. As soon as I see grams of copper, first thing I'm going to do is convert to moles. And then maybe I'm done with the question. I don't know. But this time, if I started my single unit number of grams, my grams is going to go down here, and my 1 mole is going to go on top. And my grams in a mole is going to come from my periodic table. And on my periodic table for copper, $63.55. But I'm not done. I want atoms. So I'm going to add my other conversion. 1 mole of copper. Doesn't matter. 1 mole of anything. 1 mole of pigs. 6.022 times 10 to the 23rd. Probably cover the earth a mile deep in pigs, because it's a tremendously big number. 1 mole of anything. 6.022 times 10 to the 23rd Cu atoms. So we have to do our other step, but remember, we're still using 1 mole. There's only 2 conversions you're using here. 1 mole to grams or 1 mole to 6.022 times 10 to the 23rd, whatever it is. In this case, it's atoms. If I had H2O here, I'd put molecules. If I had salt, NaCl, I'd probably put ionic compound or formula. But it is the same. In your calculator, 5 times 6.022 times 10 to the 23rd, hit equals, divide by 63.55. And 3 sig figs will work. 3 sig figs gets us 4.74 to the 22. Okay. 4.74 times 10 to the 22 copper atoms. Again, don't overthink this. Do not overthink this. You just got to get units to cancel. There's only 2 conversions we're using. 1 mole to grams or 1 mole 6.022 times 10 to the 23rd. That's it. So in the next example, we've got 28.35 grams of glycine, and we're going to moles. So 28.35 grams. C2, H5, O2, N. One mole C2, H5, O2, N. Grams C2, H5, O2. What moles we've done there. Twelve point 01. 01. 16.00. Here comes a nitrogen action now. 14.01. rounded to 2 sig figs from our periodic table. No, excuse me, not 2 sig figs, sorry, 2 decimal places. So the molar mass of glycine, if we add up 2 carbons, 5 hydrogens, 2 oxygens, and a nitrogen. $75.07. I think 75.07. 75.07. 75.07. Yes, all right. Grams are going to cancel out, right? And now, if we divide that out, 4 sig figs, 0.3776. Moles to grams. Vitamin C. Moles to grams. Vitamin C. So we're starting out with moles. Let's take this out of scientific notation. So my 1 mole's got to go down there because I'm starting with moles, right? My 1 mole is going down below because I'm starting with moles. Do we really need grams? Yeah, this is a 1-step problem. So grab your calculator. What is the molar mass for vitamin C? What is the molar mass for vitamin C? Molar mass for vitamin C. $176.17 here. No. $176.14. So 176.14 moles cross out. We get a final answer of with 3 sig figs. 0.0250 grams. In the last example, we're going grams to moles, moles to molecules, and molecules to atoms. 40 milligrams of saccharin. How many grams? How many grams? We're gonna pull this way to the left. We're gonna need all the room we can get. 0.04 grams. Grams, what's the first thing we're gonna do? We're gonna get moles, right? No matter what, we're gonna get moles, no matter what. 1 mole. How many grams? Grams to moles. Molar mass. 7 carbons, 5 hydrogens, a nitrogen, 3 oxygen, and a sulfur. (183.20), 183.20, 183.20, going once, 183.20, 183.20. What we're looking for in this is how many carbon atoms? For how many carbon atoms now? There's 7 carbon atoms when we have a molecule of this, right? 1 molecule has 7 carbon atoms because of that 7 right there. So let's get the molecules. Molecules here because everything is a non-metal in this compound. So 1 mole of C7H5NO3S would be 6.022 times 10 to the 23rd molecules of H5NO3S. Then 1 molecule. Every 1 molecule has 7 carbon atoms. All those units will cross out and we end up with 9.20 times 10 to the 20th. (9.20 times 10 to the 20th). All right, let's go to the next page. Grams a mole. Now, listen, when you're doing something in OWL or you're doing something in the quiz, please go back and look at this. Are you starting out with grams? Is the question asking for moles? Are you starting out with moles? It's the question asking for grams. If you're starting out with grams, is it asking for atoms? Please use this, right? Please use this as a guide. All right, let's do the next part here. You can see that this gets us through, we'll get right here, chapter 2, homework part 2 for all. So you can start working on the part 2. Okay, what we need to talk about is empirical formulas now. And that starts with percent composition. So percent, whoa, wait a minute now. What does percent typically mean? What does the word percent mean? Percent means per 100. Per 100. But you don't always have 100 for your sample size. If I said, what percent in this room is wearing sweatshirts? I have 100 people in the room. It would be, to find a percent, then you just take your part, the whole. Now the part here is the individuals in this room wearing a sweatshirt. Over the whole is the entire class in this room times 100. We had the percent sign, right? But the number assumes you have 100. If we say 20% in this room are wearing sweatshirts, it would be 20 out of 100, which we don't have 100 in this room though. So percent, just part over the whole. So if what is the percent composition of aspirin? What we want is what percent of this compound is made up of carbon, what percent is made up of hydrogen, and what's made up of oxygen. So we'll do percent carbon first. Percent carbon. Want to know the mass due to carbon is 9 carbons. 12.01 grams. If we have a mole, we'll just assume we've got a mole, 12.01 grams for the carbon over the whole. Well, let's do the whole. What is the molar mass? Hopefully you're starting to remember. Grab your calculator. 12.01, 1.01, 16, right? Grab your calculator. What is our molar mass for aspirin? Nine carbons, 8 hydrogen. I think we get 180.17, don't we? Multiply this by 100 and add a percent sign. This comes out to be, what it is, 4. Okay, I'll play that game. 59.99% carbon. If we do our percent hydrogen, the 8 hydrogens, 8 hydrogens. (180.17 grams). times 100, and if we add the percent, get 4.48% hydrogen. Then our percent oxygen, we're going to take 100 minus the 4.48 minus the 59.99. All three have to add up to 100. Percent oxygen would be 35.53%. Now, next time we meet, we will use those percentages. We're also going to start chapter 3. So we're going to want to print out chapter 3. I'm looking at this quiz. Able to do through 22 on this quiz. On this quiz right here, you should be able to do now 1 through 22. On the writing formulas of compounds quiz. On the writing formulas of compounds quiz. All except numbers 4, 18. That's probably it. 38. On this quiz, you should be able to do all of them except for 4, 18, and 38. On the chapter 2 quiz, 1 through 22. And then we're going to do chapter 3. We're going to start up chapter 3 next time we meet. So I'll probably send you a link that has that. Make sure you download it, print it, or load it with Notably or something like that. And we'll see you on Tuesday. Stay out of trouble. Don't smoke, vape, or get COVID.